Welcome to the session on estimation of septic tank. This is a typical isometric view of a septic tank. This is a septic tank. This is the soak pit. Normally this type of septic tanks we are going to provide it for the areas where there is sufficient water and in a semi-rigid areas where there is no sewers in the urban or semi-urban areas or in factories, workshops like that. And this is what we call a septic tank, where the night soil will come from the latrines, will be fall onto this one, and it will be accumulated here in the tank as a sludge. And this is a baffle wall that is being provided to see that the water will not disturb the decomposition of the collected night soil. Here in the estimation this walls will be estimated by long and short wall method. The long walls will be always taken from outer to outer ends, whereas the short walls will be measured inner to inner of the long walls. These are the short walls and this is the longer one. We will also look into the isometric view of this one so that you can understand better. Here with the estimation you should be very good in reading the drawings. If you are able to understand the drawing, how to read the longitudinal elevation, the sectional elevation or the plan, all these things properly, then it is easy for you to estimate the quantities. And this is the vent pipe that has been provided over the slab. I will show you that in the AutoCAD. This is the flooring, the first step and the second step of the septic tank. Here this is the soak pit. Here the clear water will go out of this T-joint, get collected in the soak pit. And this is the dry brickwork. It's the same dry brickwork will be there at the bottom. As it is not possible to turn this, we will show you this in the AutoCAD session. And around this, below this dry brick, you will be having the brickwork, you will be having the dry brickwork, and around this you will be having the brick bats of around 15 to 20 centimeter all round. Over this, you will be having the coarse sand where the soil water will get dispersed into the soil through this in horizontal direction. This is a soak pit. Now this is the concrete plan. I will show you one by one the items that has been. This is a soak pit, first step, the first step of the short wall, second step of the long wall. All these things you try to understand properly so that it will be easy for you to estimate the quantities very easily. All stoneware pipes have been provided around normally around 100 mm diameter, that is 5-inch thickness. There is a longitudinal elevation of the soak pit. Understand the concrete that has been provided for the floor. Normally it will be 0 at one end and 10 to 15 or 20 centimeters rise at the other end. It will be sloping. You have to estimate this quantity also. So have a look. This is the short wall and this one is the long wall. The baffle walls will be sitting in the long walls. There is a cross section of the soak pit. The brickwork at the top and bottom, a solid one, a dry brickwork all round, brick pads or aggregates all round this dry brickwork, and this is the coarse sand. I have shown it in a solid way. It is a sand, you must be knowing the porosity of that. Now let us, before going into the problem, let us go with the AutoCAD session. Welcome to the session on 3D model generated by the AutoCAD software. In this case, let us try to understand how the different components are being provided and the construction methods could be understood. Now, we are observing here in this case a typical isometric view of a septic tank here. This is the septic tank and this is the soak pit connected by the stoneware pipe. We will study about both the things one by one. Now, you can observe the septic tank first. This is a concrete bed that has been placed. Over this, you are constructed with the first step of the first class brickwork. This is the long wall, the short wall here. The second step, the precast RCC slab placed over the structure up to above the ground level, and an opening has been provided here. This is a vent pipe what you are observing. Let me show you one by one how the construction could be done. Now, observe, I am going to first place the concrete bed. This is a concrete bed for the septic tank. You can see the breadth and depth and diameter. This is the length of the concrete bed, breadth and the thickness. Over this, you are going to place the brickwork. Now, I am going to show you the first the long walls, and this is the short wall. Along with the short wall I have shown here, I will just eliminate that, show you only the long wall. Just a minute. Okay. You can observe here the long walls which is measured outer to outer, and this is the short wall. And inside this you are going to put the flooring. You take up the internal dimension. Over this, you are going to construct the short walls. These are the two short walls, and the long walls of 20 centimeter, whatever the dimension that is given. And this is the top view what you are going to observe. This is the top view of the septic tank. You can see the concrete bed, the offset all round. This is the long wall, the short wall of the first step, the long wall of the second step, and the short wall of the second step. These are the things which is to be kept in mind while estimating the different quantities. So, kindly have a view of all these things. Remember the components that are placed. Now, you can place the baffle wall here, where there will be a sitting of around 5 to 10 centimeter. You can see the opening that has been made in the long wall here to keep the baffle wall in position. Now, I will place the baffle wall. With a sitting of 5 to 10 centimeter inside. You can see the opening here, which are provided for the pipe that comes from the latrine. One inlet, another one outlet, which goes to the soak pit. This is the inlet pipe. Over this, you are going to place the slab. There is a slab that has been provided. You can have a look on the vent pipe with the cover for the ventilation purpose. Now also you can see the steps. I will just hide the slab and show you the steps that have been provided to come out of the septic tank after cleaning. These are the steps that have been provided with iron rods, and this is the T-joint that has been provided to take out the effluent from the septic tank and to put it means flows in this to the soak pit, a T-joint. You can have the cover for this one at the top. We will place it later. Now let us have a look on the soak pit. This is the pipe that is being taken out from the septic tank to the soak pit. We will study one by one. We will be having the solid wall for the soak pit. These are the two walls that have been constructed at top and bottom portion of the soak pit. In between these two, you will be having the dry brick bats. So, you will be having a pigeon like this. This is one of the type of structure that could be constructed for the soak pit, but in this case I am going to completely close this with the bricks, but not plastered or placed with the mortar. It is a dry bricks that have been placed. Try to understand all these views so that it will be useful for you to understand when you start estimating. Around this you are going to have the brick aggregates or the brick bats. You will be having the brick bats or the brick plates. Then there is a slab of place, sorry, we will provide the slab later. We will have the brick bats around the structure. But so it is solid, but it is not solid in nature. This is the brick bats that is being provided around the dry bricks. Around this you will be having the coarse sand. So, while estimate will try to consider all these things one by one. This is the top view, the second class brickwork at the top and at the bottom, in between with the dry brickwork. Around this you will be having the brick aggregates of 50 mm size and coarse sand all around that. This is how the structure goes with. Over this you are going to place the slab and the cover for that. Like this it will be covered. All this will be embedded in the earth. Completely you are going to bury this and the septic tank under in the earth. Now let us have the longitudinal elevation of this one. Now what you are seeing is the top view. It is a top view of the complete structure, the septic tank along with the soak pit. I am going to cut it along the central line of this pipe. We will cut it along the central line of this pipe and have a view that will tell you the longitudinal elevation of the section. We will have a cut in through the center of the pipe. Yes, you can see the section that has been made here. This is a septic tank section and this is the Now, let me show you the longitudinal elevation of both the structure. Now, this is the longitudinal elevation of the septic tank. Understand this view very clearly, which will be very useful for you to estimate the different items of the components of the septic tank. Now, we find here the concrete bed at the bottom with the sloping Indian standard paving flooring system, the steps that have been provided here. This is the baffle wall, this is the inlet pipe from the latrine which falls over here. The sludge will be collected here and in due course of time it will be removed through this opening, and this is the T joint that has been provided to take out the effluent that has been collected here, and we are not going to take it, it will automatic process that takes place and flows in the pipe and falls into the soak pit. And the soak pit, as you observe here the cross section of the soak pit, you can see the second class brickwork that have been provided at the bottom as well as at the top. In between it has been provided with either with the pigeon holes or a dry setting, dry brickwork. Around this you will be placing the 50 mm size brick aggregates, also called as brick bats. Even this portion will be filled up with the brick aggregates, the lower portion, and in the central portion you will be having the coarse sand around this. This is how the cross section looks. So, if you keep these views in mind, it will be very useful for you to estimate. Let us try to understand how to estimate the different quantities by taking a typical problem. We will go into the problem and understand how to estimate. Try to understand with respect to the problem. Take a simple problem where you have to estimate the quantity of different items of the septic tank and the soak pit, which is given in the drawing. It is for the 25 users. Septic tank is of first class brickwork of 1:4 cement mortar, and the flooring is of a cement concrete of 1:3:6, and the inside part of the septic tank has been plastered with 12 mm thick and the flooring with 20 mm thick cement mortar plastering with a ratio of 1:3 with a standard proofing compound. The upper portion of the soak pit is of a second class brickwork with a cement mortar 1:6, and the middle portion is of a dry brickwork. Roof as well as the baffle wall is of precast RCC slab. The length of the connecting pipe from the latrine is of around 3 meters, and the total amount has to be estimated with respect to the suitable rates. The first and the foremost thing is to understand the two-dimensional view of the given drawing. It is very important to understand that. Already you have seen the AutoCAD drawing. You know the different components, how it has been will be constructed in the field. Keeping that in view, and this dimensions that are given in the 2D drawing to be understood very carefully. If you understand this drawing, or if you can read this drawing neatly, understand it, definitely it is very easy to estimate the quantities of the different items. So, in many of the universities, the question paper has been set only for the septic tank part, only this part, and in some earlier university papers we find that both the septic tank and the soak pit was there. Now, I will try to solve the problem with both septic tank and the soak pit. This is the longitudinal elevation of the septic tank. Also, you have observed that in the AutoCAD session. This is the footing, the two short walls of the first step two short walls of the second step, a stoneware pipe connecting from the latrine to the septic tank, another outlet pipe from the septic tank to the soak pit, a T-joint bend provided here to provide the effluent that comes from the septic tank into the soak pit, a bend, and here you find the baffle wall, which is of 4 centimeter thick, 45 centimeter depth, connected outer to inner distance of the long walls, and a bearing of 5 to 10 centimeter will be taken here to sit this in the wall. That also you observed it in the AutoCAD. Now this is a precast slab provided, maybe sometimes with the opening and sometimes without opening could be provided. It's better you give the opening here so that any removals or anything to be done, repair work could be done through this. This is the vertical vent pipe, a cast iron pipe which is of 2 meter long, but it is given as 2 mm. You kindly read this as 2 meter high. Length of this is 2 meter high with a cover plate, with a cover at the top of the ventilating pipe called as cowl. Now if you look at the cross section of the soak pit, you got the second class brickwork at the top as well as at the bottom with a cement mortar of 1:6. In between, connected by the dry bricks without any mortar joint, simply placed one over the other. Around that you have got the brick aggregates of around 15 centimeter thick, and around that brick aggregate we have got the coarse aggregate, which is also of 15 centimeter thickness. This is the longitudinal elevation of the septic tank and the soak pit. This is the sectional plan of the septic tank and the soak pit. If you clearly read this and understand, then it becomes very easy for us to estimate the different items of this septic and soak pit. Now let us go with the tabular column format. Now here you observe the tabular column with serial number, description of the particular items, number of each items, the length, breadth and depth in terms of meters, quantity either in terms of meters, meter square or running meter. In the remarks column, we are going to write what are the calculations that we will be making for the either to calculate the length or depth that could be entered in the remarks column. This is how the tabular column runs. Now let us start with the very first item, that is estimation of the earthwork. Now look at the first one, septic tank. You got this is the ground level. So all these constructions have been done below the ground level. So you have to calculate the amount of earthwork necessary. Here this earthwork in this area. So let us calculate the length, the breadth and the depth of the section. So the length of this one is, internal dimension is given as 200 mm. Then from here to the outer end it is given as 40 mm. And this is also 40, that is 200 plus 40 plus 40, we get 280 centimeter. That is nothing but here you got the two short walls of 30 centimeter thick and offset of 10. Therefore, you can read it as 10 plus 30 plus 200 plus 30 plus 10 will get us to 80 centimeters. This is the length of the earthwork to be done. The breadth is outer to outer of this concrete bed 90 centimeter plus 40 centimeter plus 40 centimeters on the other side, it works out to be 1.7 meter. Let us calculate the depth of the section. As I said, it is below the earth level to be taken. It is 30 plus 140. 140 is to the center of this sloping concrete. So, we have to divide this into two parts, get the average thickness here. It is 0 at one end, 10 centimeter at the other end, and the remaining depth is 0.20 centimeter. Let us calculate this average depth. It works out to be 0 plus 10 divided by 2 is 5 centimeter. So, depth of the earthwork to be done from the ground level to the bottom of the concrete bed is 30 plus 40 plus this 5 centimeter here and the 20 centimeter the concrete bed. It is 1.95 centimeter. So, let us try to enter this in the respective columns. For length 2.8, breadth 1.7 and the depth 1.95 meter. Multiply all the four things, get the final product. Now, let us take the soak pit into consideration. Study the soak pit. Earthwork has to be done here for this area separately and for this area separately. So, we are taking for up to 3 meters depth, means it is 50 centimeter plus 250 centimeter here. Totally 300 centimeters we get. So, let us estimate for that. Let us find out the outer to outer diameter of the porous sand from here to here. So, this is equal to 100 centimeter plus 2 times the thickness of these walls 20 plus 2 times the thicknesses of the brick aggregate plus 2 times the thicknesses of the coarse aggregate. Totally it works out to be 200 centimeter and the depth is measured from here to here, that is 50 plus 250 is 300 centimeter, 3 meters. Along with that, we will calculate the outer to outer diameter of the lower portion. It is 100 centimeter plus 20 will get me 140 centimeter. We will find out the area of this, multiply by the thickness, that is 20 centimeter. Enter this in the respective columns. So, outer diameter was 2 meter, pi d square by 4 into thickness 3 meters, the depth is 3 meter, we will get 9.42. The lower portion of the soak pit is 1.4 meter is the diameter. So, we are going to take pi d square by 4 into 0.2 meter, we will get the find out the total quantity of this, which is nothing but the summation of all these three quantities, which is measured in terms of meter cube. The unit for that is meter cube. Next, we will go with the concrete. You already seen the concrete portion. The length is same as that of the earthwork, no change in that calculation. It is 2.8 meter. You just see the figure, you can easily understand it. Outer to it is 2.8, 10 plus 30 plus 2, 200 plus 30 plus 10. The breadth is 1.7 meter as it was calculated earlier. Double arrow mark is shown, that means it continues to the other end. Thickness of the concrete bed is 0.2 meter. Now, coming to the floor concrete, I said it is 0 at one end and 10 centimeter other end. We will find out the average thickness of that. The length of this is 200 centimeter. You can observe that length of the concrete bed is 200 centimeter. The width is measured 90 centimeter, the inner dimension of the septic tank, and the thickness is, as I said earlier, it is average thickness. 0 here, 10 centimeter here, it works out to be this much. Find out the product of this. The total quantity is 1.04 meter cube. Go with the first class brickwork for the septic tank, which is constructed with a cement mortar of 1:4 as per the specification given in the problem. Now, I am showing you the 3D model of the first step of the septic tank. This is a long wall, this is a short wall. I told you in the AutoCAD session also, long wall is measured outer to outer face. So we know the dimensions of this. The thickness of the wall all round is 30 centimeter. Therefore, outer to outer length of the long wall will be equal to 30 plus 200 plus 30, that is 260 mm. That is the first step, sorry, centimeter, 260 centimeter, that is 2.6 meter. Short walls will be always measured between the two walls, that is 90 centimeters the length. And this problem we are going to adopt long and short wall method. Now two walls are there, you can find on either side. The length is 2.6 meter, thickness of that is 30 centimeter, the height of that is, first step is 0.6 meter. We will enter that in the depth column. Similarly, we will get the for the short wall, I have skipped this one, we will put it in the next stage. The first step, it is 90 centimeter, thickness of that is 30 centimeter, depth is same as whatever you have taken earlier, 0.6 meter. Let us take the second step of the first class brickwork. The thickness of all these walls are of 20 centimeters as given in the problem. Therefore, the length of the long wall will be equal to 200 plus 20 plus 20 equal to 240 centimeter equal to 2.4 meter. Thickness of the walls, as I said earlier, 20 centimeter. Height of this is 115 centimeter, that is 1.15 meter is the depth of this second wall. Enter that. Get me the second step of the short walls. Short walls length remains same, that is 90 centimeter. Thickness of the short walls are 20 centimeters and the depth is same as the previous one, it is 1.15 meter. So now we will get the total quantity of the first class brickwork by adding all these four quantities. The unit for that is meter cube. Now we will take up the second class brickwork that has been provided for the soak pit. Now have a look on the soak pit diagram. This is a soak pit. The second class brickwork has been easier used at the top portion as well as at the bottom portion. Let us calculate the mean diameter of this one. Mean diameter is calculated from the center of to the center of the other side. That is 0.2 by 2 plus 100, means 20 by 2 plus 100 plus 20 by 2 will be the mean diameter of this one. Calculate the circumferential length of that. We are not finding out the area, we are going to find out the circumferential length of this one, the center mean diameter, and circumferential is given by as pi d. D is, as I said, it is 0.2 by 2 plus 1 meter plus 0.2 by 2, it is 1.2 meter. So we enter the 1.2 meter here in the length column. We are not going to find out in terms of areas. It is constructed in the circumferential manner, therefore circumferential length. Thickness of that is 0.2 meter. And the depth of the section at the top of the upper portion is 500 mm. Now for the lower portion also, you calculate the mean diameter, it remains same. Circumferential length also remains the same, no change in that. Enter that. Only the change you are going to find is with the thickness of this wall. the lower portion. It's 0.2 meter. Get the total quantity of the second class brickwork for the soak pit. The next one is the second class dry brickwork. We already seen that in the AutoCAD session. This is the dry brick portion between the top and the upper and the lower portion of the second class brickwork. So here also we are going to calculate the circumferential length. It remains same. There is no change in the circumferential length. It is pi into d. D is nothing but the mean diameter, 1.2 meters. Thickness of that is 0.2 and the depth is 2.5 meter. You observe it here. From here to here it is 250 centimeter. That means it is 2.5 meter is the depth. We can observe it here in the cross-sectional view. This is the dry brickwork. Depth is 2.5. Now let us calculate the quantity of the precast RCC slab. Precast RCC slab is being provided for the septic tank, as you observe here, and also it has been provided for the soak pit. The length and breadth is calculated, marked here. The length is very simple. It is the inner dimension plus the thickness of the wall. Outer to outer we are going to provide. So inner dimension of this is 0.9 plus 0.2 plus 0.2, it is 1.3 meter. And the thickness of this is 7.5 centimeters. You can enter that values here in the length, breadth and the thickness depth column. For the soak pit, you are going to find out the circular area. The diameter of that is outer to outer of this one, upper brickwork. It's 1 meter plus 20 centimeter plus 20 centimeter. It's 1.4 meter. Find out the area of that. It is 1 into pi d square by 4. Multiply by the thickness of the slab. It's 0.075 meter, 7.5 centimeter. We are not making any deduction in this case for the openings. Now you see the baffle wall here, it is also a precast element. I told you bearing has to be taken of 5 centimeters on either side. We will calculate the length. The clear dimension is 90 centimeter. We will calculate the length of that. It is 5 centimeters the bearing plus clear dimension is 90 centimeter and 5 centimeter the bearing on the other side. Totally it is 100 centimeter, 1 meter in length. And this has got a thickness of 4 centimeter. Convert that into meters. The depth of this section is 15 centimeter plus 30 centimeter is 0.45, 45 centimeter. Get the total quantity of the precast RCC slab, the summation of these three. The next item is the plastering, and as it is mentioned in the question paper, it is for the inner side we have to plaster it, inner side of the septic tank. Always the plastering will be done for the area, so it is length into depth. We have got 2 long walls and 2 short walls. So length of this short wall is nothing, long wall is nothing but the internal dimension. It is 2 meters in length, and the depth of the section internal dimension is 1.7 meters. This side for the short wall it is 0.9 meters. So first let us estimate this 2 sides, inner side. Length is 2 meter, no breadth, only depth will be taken into consideration, so 1.7 meter. Similarly, for the short wall, the length of that is 0.9 meter is the length. Depth is 1.7. So total quantity of plastering for the inner side of 12 mm thick works out to be 9.86 square meter. The unit for this is in terms of square meter, whereas other things we added it meter cube, cubic meter, now it is square meter. Similarly, you have to calculate for the flooring, which has been provided with a 20 mm thick cement mortar of 1:3 ratio with a standard waterproofing compound. Now you observe the 3D view of this. It is purely the internal dimension. So length is 2 meter and the breadth is 0.9 meter. The product is 1.8 square meter, the area of that flooring. The next one we are going to calculate is the brick bats of 50 mm size provided all around this dry brick. This is a dry brick here. Beside that, outer side, we are provided with the brick aggregates, which is having a thickness of 15 centimeter all round. So once again we are going to calculate the circumferential length. For that we need the mean diameter. The mean diameter, as I said earlier, it is a center to center distance of that particular item. So center to center is 0.15 by 2 plus 0.2 plus 1 meter plus 0.2 plus 0.1 by 2. 15 by 2 will get equal to 1.55 is the mean diameter. Convert that into a circumferential length. It is equal to pi into d mean, 1 pi into 1.55. Enter that in the length column. Breadth is, the thickness of that is 0.15 meter and depth of the section is from ear to ear. Totally it is for 2.5 meter depth. And at bottom you got the brick bats once again filled here. In this case you are filling it for the entire area. For this complete area you are going to fill it up. This is a brick bat which is provided. Therefore you are going to take it as pi d square by 4. We are not going to consider the mean diameter and the circumferential length. We are going to completely take the area into consideration. So it is pi d square by 4 into thickness of that is 0.2 meter. Now this completes the brickwork quantities, brick aggregates. Next we will calculate the chorus sand that is being provided. This is a chorus sand provided on the outer face of the brick aggregates. This is a chorus sand. Let us calculate the mean diameter. Mean diameter is, as I said, center to center, 0.15 by 2 plus 0.15 plus 0.2 plus 1 meter plus 0.2 plus 0.15 plus 0.15 by 2. That will get me the diameter, mean diameter equal to 1.85 meter. Convert that into a circumferential length, which is equal to pi into 1.85. The thickness is 0.15. A depth from here to the bottom one, it's 2.5 meter. The unit for that is also meter cube. Next we'll calculate the number of steps that have been provided for the septic tank to get down into the tank. Now by reading these figures, we find totally 4 numbers are there. 1, 2, 3, 4. So we'll write 4 numbers. Put it in only in the numbers column. All other things you leave it blank or put dashes. This is about the iron steps. Now you find here the 100 mm sewer pipe that has been provided from the latrine to the septic tank, which is of length 300 centimeters. SW indicates that it is a stoneware pipe. The length of that is 3 meters. You enter that 3 meters, and no breadth and depth. It is measured in terms of running meter, RM. The next one is the pipe that has been connected from the septic tank to the soak pit. The clear dimension from the outer end of the walls have been given as 300 centimeter, but normally the joints will be made between in the brickwork itself. That means a sitting has to be made here. Here also joint will be there. Therefore, we are going to take this seating as another 10 or 15 centimeter. Totally it is 20 centimeters of thickness. I'll take 15 centimeter as the seating of the pipe. The seating of this 15 centimeters will be taken, and total length is estimated to be 3.3 meters. 0.15 is the seating, plus 3 meters is the clear dimension, and 0.15 on the other side here. Here will be the joint. So 3.3 meters, you add up this, you will get the total length of the pipe that has been provided of I am going to write whatever that has been estimated, the different items, the 16 items that were estimated will be marked here in this one. I'll just run this because it is same as whatever you calculated, you're going to write it here. The items, name and the quantity, the unit that has been used for that particular items. So all the 16 items I am going to write. Copy down whatever it is there calculated earlier. Yes. Once you know the rate, I told you quantity into rate per unit will get me the amount. Multiply all those things and add it up. We'll get the final summation here. That will be the total quantity total amount for this septic tank and the soak pit. To this one you had another 5% extra, where around 3 to 5% you can take it for the contingency and 2% for the work charge establishment. You add up this to this one, an amount of 5%, and finally get the grand total by adding this total plus this additional amount. And let us try to understand what is meant by contingency. Normally an amount of 3 to 5% will be kept as a reserve amount, which is to meet the incidental unexpected expenses that you're going to come across while carrying out the work, which are not being defined under any headings or the subheadings of this particular items of work you are going to calculate. Any unforeseen amount has to be incurred can be taken out from this amount. If this amount is not used throughout the project, then the amount can also be used by taking a approval from the competent authority for any deviations that you are going to make while constructing the structure. Work charge establishment is nothing but a reserved amount of around 1.5 to 2% will be kept aside for the particular project. If at all you are going to employ any other extra laborers or the supervisors, anybody is employed there to make the payment to those people, you're going to reserve another 1.5% to 2%, which is called as work charge establishment. All this is things you're going to study it in detail in another part like specification. Hope you understood how to estimate the quantities of the different items for the septic tank and the soak pit, as well as how to write the tabular column for the abstract to get the total amount incurred for the project. I thank for watching the video. If you like it, kindly comment it in the comment box. And those of you who are not subscribed, please do subscribe now. Thank you once again.